Hello, professors. This is group 23. Our group member is Shu Wang, Jingze Zheng, and Qinmin Lin. The first, I will just briefly introduce our thesis, which our search. So in this article, focus on the problem of defining the minimum fitness state machine from a set of testing scenario and the temporary specification representing in the linear temporal logical. We just do some little on that because we didn't define in our states in the minimum. And then I will introduce our project. Our coding project is a turn-based simulation game. Developed in the Python use some Spade framework. It focuses on creating a dynamic farm management system where in this system the players grow and harvest crops, manage some resources, and make strategic decisions to achieve financial success. And the game adopts a module design is driven by the fitness state machine. As you can see, this we divided into module part, agent part. In the agent part, we use the finite SM. And we also do some tests to test some module or something like that. And then we also define the main function and draw picture to draw the FSM model. First, let's welcome Jingze Zheng to introduce our weather module.
Okay, my name is Qingzhe Zheng. So first module I want to talk about is the weather. This module, in order to generate some weathers randomly. So as you can see the code, first is the generate weather method decorated with this decorator can be called without instantiating the weather class. It's related to the class itself, not to an instance of the class. And then the weather use the random choices. Random choices is one of the function in random module. It is used to transfer the key of probabilities of weather into list. As the wet or as a wet to select the weather type, the values of the weather probability dictionary are converted to a list, which is used as a wet for selecting the weather type. K equal 1 means we only choose one element. If you are in doubt about this function, you can run the test weather field in the test module.
And pardon, before do the tests, we forgot to introduction the configure. This configure is just a global variable. It's convenient for us to invoke some global variable. And as the weather function, we use the weather probabilities that we defined it before. As you can see, these probabilities, we defined it in different between the different season. And we can do the test.
Yeah. So the test weather function is defined to test the functionality of the weather module. It begins by printing a message indicating that the testing process has started. In this step, we defined a variable called test iterations, which determines the number of tests to perform. We set it to 1,000 to gather enough data for statistical analysis. Here we test the weather generation during the rainy season. First, we print rainy season as a label. Then use list comprehension. We graduate weather results 1,000 times for the rainy season and store them in the raining results list. Next, we calculate the frequency of each weather type using a dictionary comprehension. The frequency is calculated as the count of each weather divided by the total number of tests. Finally, we print the frequency dictionary to display the results. The results of this test are the result distributed of this test is very closely to the probability distribution we set before.
Yes. Yes.
Yeah, so the drought season is the same process. And next, I will talk about the timer module. In this part, we importing external modules. The weather class is used to generate weather conditions, and day pre-season is a configuration constant representing the number of days in season. This is the initialization of the timer class. It simulates the passage of time. The init method initialize several attributes like current day starts at 1, days pre-season, and the day's duration are parameters passed when creating an object. Finally, seasons is a list that contains the names of the seasons. The tick method simulates the passage of a day by incrementing the current day attribute by 1 each time it is called. And the get current season method calculates the current season based on the number of days passed. It divides current days by days pre-season to determine the season index, and it uses the modular operator to ensure the season's loop. The get weather method generates the weather of the current days based on the current season. It first retrieves the current season using the get current season method, and then calls the generate weather function from the weather class. The get total days method simply returns the current day attribute, which represents the total number of days passed so far. And next, Chu Wang will introduce the group.
Okay. Yes. My name is Chu Wang, and this part we define something about the crop. So we firstly defined a class crop, and we define a function that accept two arguments, which are crop type and plant day, and then we define some attributes about the crop, like the crop information, the crop type, the crop max growth, and the crop sale price, and the crop name, and of course the crop description. And we initially defined the crop states is unripe, and of course the crop's plant day. That means the day that the crop be planted, and then we define the method named grow, which is responsible for updating the growth and the state of the crop. And it's accept two arguments, which are current day and weather. And we should think of a situation like if the crop is already in the whited or the ripe stage, so there's no need to update its growth. So we just we define a variable called the day since planted, which use current day to subtract the self-planted day to get the day since planted. And we should also think of the weather, which will accelerate or slow down the day of the growth. And if the weather is raining, then the growth +2. And if it's sunny, then growth +1. And if it's cloudy, then the growth plus 0.5. And if it's snow, then we should set the ripe states as wilted. And if the weather is an unknown type, it should print a message on the screen indicating that, and don't make any growth adjustment. And if the growth value of the crop has reached or exceeded its maximum growth value, so we should set its state to ripe. And then we also defined a method named harvest, which is used to harvest ripe crop and update the fruit bag. As we can see, the harvest function, we use a dictionary named fruit bag. And if the crop states is ripe, so we should increment the count of the current crop type in the fruit bag by 1, and update the state of the crop to harvest, and also return the dictionary with the number of harvest crop and the profit. And if the crop is not ripe, we should return the dictionary indicating that no crop were harvest and have the profit of 0. And at last, we define a method named getInfo. It's used to return some information about this crop. Yeah. And then it's time for Qin Milin.
Hello, Professor. My name is Jimmy Lin, and let me introduce our agent. So first, as you can see, the left sides, we write 1, 2, 3, 4, 5, 6, 7, 8, 9 class, and 7 is state class, and 1 is FSM behavior, and another is the agent. So first, let me just do some introduction in our state. In our state, we have the start state. As you can see, in start state, we define the run functions. In this function, we just initialize the player's code with initial amount defined in our initial code, which we just write in the configuration file. And another is weather update state. In this state, the weather will be changed in randomly. Just we write the weather module. We just invoke the get current season method we write before, and print notification to tell the player the weather is changed. and another is the daily. In the daily state, the players is the journal state. In this state, the player can get into different state. As you can see, we defined some, we use the if-else statement to tell the player whether they want to, what type of state they want to go, whether they want buying seeds, planting, or harvest, or just do the weather update. When they do update, that means we just skip a day. And another just tell the player that is invalid choices, try again. This make our system more robust. And in buying, we just do same things, but we write some functions to let player to buy our seeds. In the planting, we just do things that users to plant in their seeds. In the harvest, we just invoke the harvest crops function we written before in the crops module. And weather update, I forgot to tell you that we just invoked the get current season. We written this function before in the timer module. That's the very tedious things. And the end, we just write some if-else statement to track the statement that the user win or failure. And in this agent, we first do initialization. This is the same thing we do it before in other module. And need notice that is the crops, that is the list data structure, because we think this is the best way to store all the grown crops. And also we use the synchronous event to indicate whether the FSM is complicated. It's very useful when the event is complicated. And also we do the step up function. We first initiative the FSM. We just write these classes. In this class, we just inherit the journal FSM behavior in the spade library. And we also define the two functions, on start and on the end. Need notice is that we invoke the FSM complicated set function to mark the FSM behavior has been complicated. This all things is very similar in the official document. We just do same things like they do in the example. And let's continue introduce the player agent. And in the update corps, we just use this function to automatically update the growth state of all crops. And we also have the plant crops to grow crops in the batches, because there are some crops you're planted in the different days, so their harvest day may be different. But in one day, they will grow up the same. And we also have the harvest crops. In this function, we just harvest all mature crops in batches. We use the for loop to traverse all the crop list, and we update our fruit backpacks. We harvest this fruit back in our result, and we can automatically communicate the profit because the time limits we didn't write a state that the player can sells their fruits. And also in the harvest, so in the harvest groups, we just update the player coins. If we wanna add the sales states, we think it's very easy things, but it's very tedious and also have some time limits. So we just brief this state. And also we have the short state. In this state, we can display the players or current status. And also we define the function that check end condition. In this function, we just write some if else statement to check the result whether is end. And you can see in the daily state, we first write this statement that if the game failures, we are directly into the state end. And in the setup, we defined some state and defined some transaction. And the reason why I use some space, because I think it's more logically looked more logically. And we can see this picture. It's our FSM model. As we can see, we first at the start state, and then we directly in the weather update state. And then we will continually in the daily state. In the daily state, the player can be getting to different states like buying, planting, or harvesting, or weather updating. That means directly skip the day. And in the different, in this four state, the player can directly return in the daily. And if in the daily state, the player maybe wanna check their state, so we add a transaction from daily to daily. And in the daily state, I hope you not forgot in the daily state, we write if else statement that will not return, that will check whether the game is in the end or not. And we can do some example in our terminal. We first could run this main function. Oh, I forgot that true1 to introduce our main file.
Yeah. And it's like our main function. It's first just show some notification in the screen, like welcome to our games and something like that. And after that, you should enter your XMPP account and of course enter your password to to presumably for the server authentication, and then and then it's for creating agent instance, like and then it's called the player agent, and then we use the start function to start this player agent, and then it's for some notification showing it on the screen. And then we wait for the FSM behavior to complete, and then it's stop the player agent. Yes.
Yes, first we do some tests. First, invoke the main function, and then we can input our account. That means if you have XMPP account, everyone can play this game. And if they have not time limits, we will do some visualization interface. My passport is false, so I will log again. Wait for the network connecting. What the hell? Why's the result is that?
完了。
What the fuck?
Maybe I will use another account.
我觉得没什么关系，因为我们还可以 PS。
我也觉得，等一下把这两个接在一起运行的。
啊，
Okay, I got in. As you can see the instruction. Welcome to the Moondew Valley. And some briefly instruction. And the system will tell you the name, player name, and do some explanation. Yes, we are in the daily state for right now, and the weather is sunny. If you want to check the state, you can print 5. But if you want to skip the day, you can press 4. You can see it's also day 1 is sunny and today is raining. In the rainy day, we may be planting crops, but it's too late. What the hell? Maybe the network is failure. I will do some tests another time. So that's all. Thanks for your watching. 录制. And now we are do some tests. First, we invoke the main file and we input our account. We can buy seeds first. We can buy joint. seeds. And we want to buy 5. That means we need 15 gold. And we still have 25 gold. And we can plant these crops. We wanna plant in the raining seeds. And we have 3 seeds, we can press 3. And we can also plant the crops. We want to plant the drought seeds. We have 5, so we can press 1 or 2 something else. But I hope we can plant whatever we have. And we can skip the day to wait the seeds grow up. And the day is sunny. The season is rainy. We can also skip the day. And today is cloudy. We can press 5 to check the state. As you can see, we plant the 3 raining. The state is reap because the raining seeds need 2 days to grow up, but the drought needs 3 days. So they are not unreaped, but we can harvest press 3 to harvest the raining fruit. And we can also skip the day. And the season is short. The weather is rainy. We can check the state. Yes, hey, the Jones is grow up. We can harvest now. We just harvest. Oh no, something failure to send the setter. Maybe it's the network. It's not our fault. As you can see the XML string not connected. Something is old. Failure future is already done. So maybe I will do the completely test. We'll do fast test. I will not say anything. Yes, we have stored the crops. That we totally have 117 goats. That means we got win. I can use another count. Maybe I press wrong the password. I will press my keyboard very slowly. We wanna buy 10 seats. The result is fail because we have not We not have any money now, so the game is over. That's all. Thank you for your watching.